This is a photograph of Lake Tahoe for those of you who have been there. It looks like that when the northern half of the state is not on fire. I know there's a lot of smoke in California and in the fires that are burning in the western U.S. this year, which have been terrible. It really ruins the views. But this is a beautiful lake. So today we're going to be talking about the Truckee River Bridge Scour project, doing it by the book. As far as the agenda is concerned, I want to give you a little bit of just background on the location of the project, what we were doing, what the project looked like, talk a little bit about some of the challenges that we had, maybe not unique to this project. We all have challenges in our endeavors. Talk a little bit about the experiences we had in trying to come up with Scour. You know, it's just, we got the book, right? You just calculate it out. But, you know, there were some nuances that I want to just bring to your attention. And then we'll have a few minutes for questions. So we're pretty far east here, but this is located, for those of you who don't know, on the border of California and Nevada. And if I just kind of blow this up here, Lake Tahoe actually straddles the border. About 2/3 of it is in California. And the project was really located in Tahoe City, California, on that, you see in the red circle there on the northwest shore. So just a little bit about Lake Tahoe. Just curious, by the raise of hands, who's been to Lake Tahoe? Okay, so almost 2/3 of you. That's excellent. It's really a beautiful lake, and it's about 22 miles long, north-south, about 12 miles wide, east to west. It's a very deep lake, ranking among one of the deepest in the world. Tons of storage volume, and it's a high mountain lake. You know, a water surface elevation over 6,200 feet. With the surrounding mountains even getting up to close to 10,000 feet. I know here in Columbus, Ohio, their annual average precipitation is about 38 inches, but for a western arid area in the U.S., 32 inches is quite a lot. Now, 75 inches of that, not snow water equivalent, of course, is in snowfall, just due to the seasons in the winter. The Truckee River is the only outlet to the lake, and about 150 years ago there was a dam built there to control the releases, and almost 100 years ago it was rebuilt. And the Bureau of Reclamation operates it. It's got a bunch of radial tainter gates that control the flow out of Lake Tahoe and control those elevations. Again, for those of you, and many of you have been there, it's a beautiful area of the country. It's a lot of tourism that's there, a lot of use, a lot of mountain biking and camping and backpacking and use of the river and use of the lake. Let me just show you just a few photographs here of the lake. I know you can Google these and see all these. The lake is unusually clear. It's part of its allure, part of its beauty. Day, at night, again, this is the same picture, but at night from the title slide, kind of a vantage point that people use a lot. The Truckee River is used for river rafting quite a bit. It's very environmentally sensitive. I remember rafting there with my family on a rubber raft at age 10. It's not a real fast river, but it is really a lot of fun. So this is a picture of that dam that was rebuilt about 100 years ago. It seems to have an allure of its own. It's very beautiful. People like to stop and look at it. Okay, so let's kind of look at the proposed project. This is just a satellite aerial view of Tahoe City. And you can see on the right, we've got Lake Tahoe. This is the Lake Tahoe Dam that I just spoke about and showed you in the photograph. And the Truckee River, of course, comes out of it. The yellow lines you see here shows most of the project we worked on. Some of it is to the south, it's not shown, but these improvements were being made. There's a couple of roundabouts that were carefully designed, a couple of existing roadway corridors that were improved, and one corridor that was punched through as greenfield. Now, there are two bridges. One bridge is called the Fanny Bridge. It's an existing bridge. It's been there for a while, and that bridge will be replaced. And then there was a new bridge spanning the Truckee River, which will be the new Highway 89. Currently, the Fanny Bridge is Highway 89, and that'll be moved to the new location to relieve some pressure and stress off that little community there. So just a note about the Fanny Bridge. This is a photograph of it. It's 4 spans with three pier bents. I mentioned just now it's the current location of Highway 89. The existing deck will be completely removed and replaced, but the existing piers will be completely removed and not be replaced. So it'll span the entire river. One interesting aspect of it is the existing abutments on the existing Fanny Bridge are to remain. New abutments will be built behind them, and so the river will still see the existing abutments. And I can't recall if that was for some aesthetics, but I just thought it was kind of interesting on a new bridge. Now, why the name Fanny Bridge? I'm curious if anyone here knows why it's called the Fanny Bridge. Why is it called the Fanny Bridge? So this is a picture of what you see as a motorist, and people like to just stare at the dam and kind of show their backsides. Thank you. You're 100% correct. All right, so this is just a graphical still shot that was a simulation that was put together of the southern southwest roundabout showing the new proposed bridge over the Truckee River. Now, it's a dated photograph. Some of the design had changed, but I want to draw your attention to the multi-use paths that go beneath the bridge on both banks, both sides. And they'll be used by cyclists and pedestrians and joggers and everybody. This is a little closer shot of that same bridge, but I want to draw your attention to the concrete columns that are shown on both sides between the trail, the multi-use trail, and the river. Another shot which shows those columns a little bit better from the ground, from the perspective of a user of the trail. But really, I know there's a rubber raft in there, but this river is very heavily used for all these recreation. All right, so this is just a simulation, a motion simulation of that same intersection, just probably focused on some of the traffic patterns. I'll just have this run through twice real quick. But again, just showing how pretty the area is. You know, a lot of pine trees there that had to be worked around when we were doing utilities and roadway improvements. This project is still under construction, by the way. This is just another motion simulation from, I guess, the fish's perspective, but dated again because there's no columns there shown on that trail, but gives you kind of a sense for, again, the beauty of this area and the care we wanted to take in preserving much of that. Okay. So I want to talk just about a few of the challenges that we had. Maybe these aren't unique to this project, but we did inherit this analysis and this project from another consultant, and I've been on the other end of that. It's not a bad thing. I know we're all different as engineers and practitioners, and if we are all put in a room with the same scope and the same budget, we might come up with some different things. But sometimes it's a challenge to know, okay, what were they thinking? You know, what were they doing? Why did they do it? How did they arrive at that conclusion, not knowing all of that? So that was a little bit of a challenge. No adverse impact was required for the 1% base flood. It's not unusual. Again, there was a regulatory FEMA floodway in the area, but we wanted to be careful with county and local requirements not to increase the water surface elevation above existing conditions, even with the improvements we were making. Multiple agencies and stakeholders were involved, and again, that's not unique to this project. Now, this was a Federal Highways, Central Federal Lands project through the Highway Division, part of the Federal Lands Access Program. And they were actually the client of ours, and they were fantastic. And it was a great experience for me to be able, unlike some of our private clients, to be able to converse on a technical level about some of the hydraulic questions we had and some of the ideas we had. So it was a very positive experience for me. Being in California, the local Department of Transportation was heavily involved. I believe they're maintaining the project, and so, and that's a huge organization, and they're going to have their thoughts and feelings about it as well. The county was involved, a local regional planning agency was involved, the Tahoe Transportation District was involved, the local public utility district was involved, the U.S. Forest Service was involved, and with the proximity of this project to the dam, the Bureau of Reclamation was also involved. Not a bad thing, but just a lot of entities and folks to talk with and to work things out. It did make things a little challenging for design criteria and standards. For those of you who have done drainage work anywhere, you might be able to feel what I'm saying. You know, just coming up with simple things like what discharge and frequency of storm to use for hydraulic freeboard or for the Scour analysis was not always clear or in agreement. How countermeasures would be viewed for these new bridges on the local abutments, and how that related to what kind of depth protection we had to provide for Scour. You know, just little semantics or nuances about is the top of the footing, the bottom of the footing, and some of the manuals that Federal Highways had and Caltrans had, and trying to, you know, mash them all together. And again, just in general, just some unclear wording or some contradictory standards we had to work through. Okay, so I just want to talk a little bit about the bridge structure itself. This is a plan view of the proposed Highway 89 bridge. I'm just showing the deck and the approach slabs there in the red outline. And here are those four columns on each side of the bridge. Pulling that up in elevation view, you might say, Gall, you know, there's just two box culverts there that are supporting this bridge, but of course it's not the case. And bringing that down, you see those same columns. And I just want to kind of home in and focus on that one abutment. These are cellular abutments. They are considered shallow foundations, and you see that red column there, and the rest of this area in yellow is just, that's the abutment. It's not unheard of. It just doesn't match every picture you might see it in a Scour textbook of these deep piles that are going down to bedrock or deeper to support the bridge. It was interesting, the conversations that sparked among some of my colleagues and peers just about the abutment toe. And if you look at the past editions of HEC 18 or some of the computer software we use on a spill-through abutment, even though the abutment, the structural abutment itself, the member itself might be set back supporting the bridge, you've got this sloped spill-through fill. And we often regard that toe of fill where it intersects the natural channel as where the scour might occur, especially if you're set back from the channel, the main channel, far enough that you don't have to worry about the deeper depths and velocities. But again, on this, you know, where's the abutment toe? You know, where do you think it is? And people have different opinions. We've got the footing. There was a concrete curtain wall that dove down into the ground a little bit. At the end of the day, we had some sheet piles that were in there as well as part of the construction process. But there was a 5-foot shelf on the river side of the column, some riprap countermeasures. And for the 1% base flood, this trail is inundated. I know the goal was to have this trail operational through more frequent storms, but for the 1% flood, it is inundated. Now, I'll just mention this wasn't considered a pier from a scour perspective for the very simple fact that it wasn't in the ground. It was surrounded by concrete and asphalt and even countermeasures. And I guess you could argue that there might be some zone of influence around it, but it wasn't considered a scourable pier. But again, where's your abutment toe? And without getting into a detailed discussion, these red dots were all different things that people had said. You know, is it a vertical wall abutment? Is it a spill-through abutment? You know, where's the toe if this is back on the floodplain? So you'll read over and over that some of the traditional methods like Froelich or Heyer can overpredict scour. And I know we've talked a lot about that yesterday, about these equations in HEC 22 or HEC 18, how they ain't right, you know, they have a little bit of fluff in there, but this newer NCHRP 2420 method, which I believe was published in 2010, and then included in HEC 18, the 5th edition in 2012, a couple years later, is often being requested or looked at by DOTs and other agencies as, hey, this is the new thing, we want to use it. And I just want to mention a few things about it, and many of you know these things already, but the local abutment scour computation that you do already includes your general horizontal contraction scour. I know that's a little bit different. Typically, those would be additive to what you would come up with. Be aware of elevation reference points for your final scour depths or prism. I know we discussed this on this project, and again, if you're close to the main channel, you may want to consider the Thalweg, the lowest elevation in the channel, as your reference point due to lateral stream migration or whatever. I mean, it might be a little conservative in some people's minds, but we need to be very careful of that. The computer programs, I remember Veronica sending me an email saying, hey, make sure you check all the default values in HEC-RAS, and she was 100% correct. HEC-RAS gets it spot on half the time when you're running that scour design function. But for one reason or another, just depending on how the model is set up, sometimes it can be miles off, and you really want to check those. And bugs, I mean, it's just a reality of software. Bugs happen. Yesterday, my financial app on my phone said, hey, we're updating due to these 27 bugs. And I thought, well, what have you been doing for the last 3 years? You know, I don't know what it's been doing. But it's just part of the software gig, and we make these improvements and changes. Also, you may find with the equations that a more frequent storm may produce a deeper scour depth than a less frequent event. I don't think I have to tell this group that sometimes the methods and the equations don't cover all the situations. Research and refinements are ongoing, especially with this group here, and these multi-100-page NCHRP reports that are coming out all the time, and technical briefs or addenda or new versions of a manual, eventually get into the new manual and make this process better. We're finding out there's interaction between the scour mechanisms, that local pier and abutment and general contraction and pressure vertical contraction scour are affecting each other in maybe non-linear, non-additive ways. HEC 18 itself needs updates. It's a massive document, and I sing its praises. I mean, the fact that we have this wonderful manual through decades of people who without all the computing power that we have put this together is amazing to me. But oftentimes it needs updates, and those take time, and they take care. The pressure flow issue on the Fanny Bridge on this project for the 500-year flow, the bridge was overtopped. And the nchrp 2420 method doesn't really work or is not really suited to work with the current research for pressure flow conditions. So we had to figure out what we were going to do. We had to design something. We had to get something on paper, and we had to stamp it and feel good about it. If you really read deeply into HEC 18, you'll see references to cohesive and non-cohesive soils. And I know yesterday we talked a lot about the geotech aspect of scour and what all that means and where we're going with that science and research. But you'll find sometimes you're in a corner where your bridge or your soil, at least the soils data you have, doesn't fit the picture of what HEC 18 is telling you to do. So you have to use some judgment. Just a couple other slides and we'll wrap up. But as kind of a side note, there was kind of a flood during construction. There was a very, very wet year in this area. And one day I remember we received a couple of photographs like this and a memo from a local agency and stakeholder that said, hey, you underpredicted the water surface elevation. They were concerned that the trails were going to be underwater more often than they were happy with. But we didn't get any survey information. We got these photos. We had to look with our calibrated eyes on where this water was. We assumed the construction was per design. It was based on assumed release rates that we were being given by the Bureau of Reclamation. The grading and the construction wasn't even complete. Typically, we have a model for your pre-project existing conditions and a model for your completed conditions, but not always for every phase in between. And again, we inherited the model, including topography that was 10 years old or so, and the boundary conditions that were set in the model, and we weren't scoped to do a real deep dive or independent validation of those things. But either way, we took this very seriously and made some adjustments to the model and then ran those through the Scour calculations. So just kind of to wrap up in summary here, I know you all know this, and I know a lot of the high-end researchers in this room are also professional engineers and are licensed as such, but there's just a huge mob of engineers out there who just work as practitioners, and they have to balance their knowledge of material science, hydraulics, geology, physics, economics, and engineering all together the best they can. They don't always have the luxury of spending their entire careers or even years of their career on one piece of software or one thing. They have to have 40 pieces of software they have to be adept in and 40 different things. And they find themselves at that nexus of all of this. But it is their responsibility, our responsibility to study and to research and to know what we're doing and to act within our area of expertise. Visit the library in quotes. My kids the other day didn't know what an encyclopedia was. Had to explain it to them. But I mean, the amount of online peer-reviewed research and manuals that are online are just fantastic. HEC 18, as I mentioned before, is our standard reference. And I look forward to, I think in the relatively near future, there might be some updates and clarifications that supersede or clarify some of the things that are in HEC 18, maybe a technical brief or two. Not everything in these manuals is perfectly clear or textbook. It may not match your situation, and I love that we have the resources with Federal Highways and other colleagues to help us out in these situations. And the book changes, as I mentioned. Be aware of updates, and that's hard to do if you only do a Scour project once every 3 years, but you owe it to be aware of what's coming out and what's on the horizon. I love that we were able to reach out to internal and external resources in our client and to have good, meaningful conversations about this situation or that situation and what we should do. And of course, sometimes you have to use sound judgment. We talked about some risk-based approaches yesterday with Scour, and so sometimes you have to do that. And finally, just kind of be consistent in what you do. I've heard it said of hydrology, you can't be proven wrong, but you can be proven inconsistent. So it's important to follow the current standard of care and what's currently practiced at the time, and of course document all that you do. I don't know about your memories, but memories fade. And a good report or a good document, even if it's just to remind you of what you did and why, speaks volumes and is very, very valuable. So that's all I had today. I appreciate your time and attention. I think we have a few minutes for questions if there are any.
Just a quick question. Looking at the site photos that you had, it looked like the bed material was pretty coarse. Maybe had some armoring. But I could be, my eyes could be completely deceiving me. I was curious if you could speak to the type of sediment that you were concerned with when you're calculating your scour depths.
Right. Thank you. Good question. So for those of you who didn't hear that, he just asked about the type of soils we had from the geotechnical information. I had mentioned before that we inherited the project, and so some of that work had already been done, and in the D50, even though that's only one soil particle had been decided on, it wasn't a fine cohesive material. It was considered a non-cohesive soil. I don't recall seeing much stratification. This river is a pretty slow-moving river when it's not flooding and stuff like that. Again, they had that very, very wet year where they were releasing a lot of flow out of the dam, but the soils were pretty consistent. The D50 was, I don't remember the value, but I know it was larger than 0.2 millimeters and considered non-cohesive. So all of our stuff was in the non-cohesive realm. On a recent project, I had to work on Scour on a complex pier. These were piers that were 200 feet high and in very fine sediment and cohesive soils. And I'll say I struggled finding the exact procedure I was supposed to be using in HEC 18. And maybe someone after I step down can bang some sense into me and show me on page 6-6 that it says it right there. But yeah, it's not as bouldery as I've seen in my work in Colorado, just kind of a slow moving, and it was a non-cohesive soil type. Thank you for that question. Any other questions? Yes?
What was the reason behind adding the column?
So not being the structural engineer on this project, they wanted to go with a cellular abutment. I guess you could have punched a culvert, like a tunnel through there with all the security issues that would have. They wanted that daylight to come through on those trails. I think the columns are just part of that cellular abutment structure. And again, that's an excellent question, just maybe for our structures guy, why he selected that shallow foundation. I know they looked at a GRS IBS bridge type of configuration, and I don't know if prior to us receiving the project they looked at deeper friction piles or whatnot. But they really wanted that. That river's beautiful. They wanted that to be open to the daylight and be more safe for the folks who were using those trail systems.
I think, I was involved with that project as well with Brad, and part of the reason too was if we didn't have those columns, the supports, the beams would start getting too deep, and because you'd have people riding bikes and walking under there, you couldn't do it.
Yeah, thank you, Veronica, for that ad. I remember back to that flood I mentioned in the presentation, how they thought the water was a little higher. The designers and the contractors out there wanted to raise the trail by 2 feet to get a little bit more freeboard, if you will, for the trail from the 10-year or even the 50-year flow events. The clearance in there was 12 feet. And we were told over and over we had to have 12 feet. Well, they raised that up and they have 10 feet now. And apparently that was okay. And I know you hear 10 feet sometimes for equestrian use and things of that nature, but you're right. It was partly, I'll bet, a vertical clearance thing with the structures on there. Thank you for the question.
Any other questions? Okay.
Thank you.